Early in the semester, we talked about the natural numbers, which are numbers 0, 1, 2, 3, just sort of your counting numbers. And today we're going to be discussing integers. So integers are basically the natural numbers combined with all the negatives of these natural numbers. So like -2, -1, 0, 1, 2, etc. Okay. And specifically, we're going to be talking about addition and subtraction of these integers. So things like -5 plus 2, or -8 plus -2, or 3 minus -4, things like that. So when young students are first learning how to perform operations with negative numbers, it's good to have some sort of models to go off of. And these models could be real world models, or they could be just like classroom models or whatever. So some examples of how we can model things like these in the real world would be, so -5 plus 2 would be like maybe like in football or something. It's like a loss of 5 yards combined with a gain of 2 yards. -8 plus -2 would be like a loss of $8 plus an additional loss of $2. And 3 minus -4 could be like, well, you have $3 and maybe you owe your friend $4, but you do them a favor and you end up getting rid of that $4 debt. And so you have $3 and then you get rid of a $4 debt. So you're kind of gaining a net of $4, something like that. Right? So those are all well and good. But next I want to talk about some like more so classroom models for integers. The first one I want to talk about is the number line. So for example, I could represent the number 2 on the number line with just an arrow starting at 0 and pointing towards the number 2. Okay. The number -3 would be a left-facing arrow starting at 0 and pointing left towards the number -3. It's important to note that the lengths of these arrows correspond to the whole number, ignoring the sign of the number. Right? So the length of this arrow is 2, the length of this arrow is 3. And the number line is really good for addition. So if I wanted to do 2 plus -3, I can really just concatenate these arrows. So I start with 2, and then I take -3, and I sort of just tack that on to the end of the arrow and see where I end up. And where do we end up? So let me just gray that out for a sec. So we end up pointing at -1. And so this is equal to -1. 2 plus -3 equals -1. The next model I want to talk about is the set chip model. So with the set chip model, you use a combination of chips. So here I have like black colored plus chips and some blue colored minus chips. You could use red and black chips. I think the book uses red and black chips a lot. And so one of the chips is going to represent positive numbers and the other one represents negative numbers. So here the number 4, +4, can be modeled with a set containing 4 of these positive chips. One of the key features of this model is that you can represent numbers in different ways. So I could also represent the number 4 as over here. So here I have 6 positive chips and 2 negative chips. So 2 of the negative chips will cancel with 2 of the positive chips. They form like a canceling pair, you could call them. And after they cancel, you're just left with 4 positive chips. The number -3 can be represented similarly with 3 negative chips, or you could represent it with, say, 4 negative chips and 1 positive chip. You would have this canceling pair right here, and then you can see the equivalence between these two. This model, combined with the fact that you can represent numbers in different ways, makes it pretty easy to model addition, because if I wanted to model 4 plus negative 3, I could really just take these 4 positive chips, these 3 negative chips, and then just combine them together. And so when we do this, we then just have to figure out, well, what do we get after we get rid of all the canceling pairs? So we have 3 positives cancel with 3 negatives, and then we'll just be left with the 1 positive chip at the end. And so we're left with 1 positive chip at the end. So 4 plus negative 3 is equal to positive 1.